Hello, my name is Andy Gallardo. I'm a PhD student at Carnegie Mellon University, and I'll be presenting a talk for our paper, Interdisciplinary Approaches to Cybervulnerability Impact Assessment for Energy Critical Infrastructure. This work was done with my collaborators, Robert Erbes, Katya Blanc, Lujo Bauer, and Lorrie Cranor. Protection of energy infrastructure is an immensely critical security problem. Disrupting energy grid operations can have severe consequences for society. The loss of power can cause ripple effects that impact other critical sectors and services, such as hospitals, financial services, agriculture, and energy production and distribution. Attacks on the energy grid are becoming increasingly common and highlight the growing threat to critical infrastructure. Here are just a few of the many news headlines about attacks on the energy grid in the past few years. Traditionally, energy systems were independent of information technology or relied on blocking connections to external networks. In energy operational contexts, the security of operational equipment was considered in terms of equipment failure or misuse. However, energy grid infrastructure increasingly relies upon computers and computer networks to operate, with operational technology now including network devices such as smart meters, laptops, and wireless sensors. With this growing reliance on networks, energy OT infrastructure becomes increasingly vulnerable to cyber attacks through exploitation of computer vulnerabilities. Additionally, there is a well-documented shortage of computer security professionals generally. So it is not possible to just hire lots of cybersecurity staff, even if that's something that all utilities could afford. IT security approaches are often inadequate for energy operational contexts, which face challenges such as legacy systems that run on old operating systems, which make them vulnerable to known exploits, as well as the need to operate continuously, which can delay patching and updates. Furthermore, smaller energy facilities and utilities may lack resilient defenses and recovery plans due to limited financial, staffing, and computer security resources. Protecting the power grid is not limited to understanding vulnerabilities. It also requires an understanding of how its operational technology contributes to the generation, transmission, and distribution of energy, and of how computer vulnerabilities can impact these energy production processes. While defending the energy grid requires understanding both domains, prior work has shown that there are major differences in securing information technology and securing operational technology, including differences in workers' training, knowledge, and culture, regulations for IT security versus OT safety, and conflicts between IT policies and OT continual operations. So what can utilities and power plants do to secure energy OT as it increasingly involves IT? One approach is to foster collaboration between energy operators and computer security professionals in order to build cross-domain knowledge. Such cross-domain knowledge will help energy OT professionals make better informed decisions about how to address risks posed by computer vulnerabilities, and also help computer security experts develop security measures that are suitable for energy environments, whether on-site or designing industry-wide standards. In our study, we're concerned with two types of subject matter experts, or SMEs, whom we refer to as energy OT SMEs, who are operational technology experts with experience in energy systems engineering and operations, and cyber SMEs, computer security experts who research industrial control system security. Our work aims to shed light on these differences with the aim of helping foster cross-domain knowledge and collaboration. Our research questions were: 1, what information do cyber SMEs and energy SMEs need when assessing the potential impact of computer vulnerabilities? Are there notable differences between the two groups? 2, what do these experts consider to be the differences between the two groups' approaches to impact assessment and understanding of vulnerabilities? 3, what insights or suggestions do these experts provide that directly address collaboration between the two groups for building cross-domain understanding? We conducted semi-structured virtual interviews with 18 subject matter experts, lasting 60 to 90 minutes. All participants were employees of an energy sector organization, and all of them had interdisciplinary experience working with the other kind of SME. To analyze the interview transcripts, we conducted qualitative coding, developing 2 code books, one with a priori codes for impact assessment strategy topics related to computer security and vulnerabilities. The other codebook contained themes that emerged from the transcripts, which we sorted into 3 categories: stereotype, occupational motivation, and suggestion. Following the research questions, our interviews explored what information energy OTs and cyber SMEs found necessary to assess impact. We asked both unprompted, open-ended questions to capture their self-reported approach and prompted questions about factors that might influence their approach. We also asked participants for their perspectives on how each group, their own and the other group, approached impact assessment and how well each group understood vulnerabilities. We expected cyber SMEs and energy OT SMEs to show a stark imbalance in their approaches to vulnerability impact assessment, but we did not find this to be the case. When self-reporting their approaches, both groups responded similarly at a general level. Both groups also displayed knowledge about both domains, perhaps due to their interdisciplinary work at the same organization. Yet we also observed notable differences in the details of their self-reported considerations. While cyber SMEs displayed a more adversarial focus, energy SMEs focused on holistic system-wide considerations. Stereotypes that participants conveyed about each group included the idea that cyber SMEs tend to protect systems by cutting off access, and that energy OT SMEs take shortcuts and bypass security measures for the sake of convenience. You can find more details about these stereotypes in the paper. Finally, we collected participants' suggestions for interdisciplinary collaboration, which we will discuss at the end of this talk. As we dive into some of the participants' responses, I want to highlight that not only did our participants show similarities in their impact assessment approaches, they also displayed cross-domain awareness in their responses. For example, Energy OT SME E7 understood the exploitability of OT equipment, saying, "From the perspective of the maker, the people who install it, and the protection and controls people, a protective relay is a device that quickly and reliably reads electrical voltage and current, then does some math on them to determine whether or not to send a trip signal to a breaker. From the adversary, cybersecurity perspective, this thing is a computer. It's got a full-blown operating system. If I have the right passwords or I can figure out how to bypass the different protections on it, I can make this thing do anything that a computer could do." In contrast to the stereotype of wanting to block connections, CyberSME C17 was able to recognize the importance of having debugging access for operators of an energy system, saying, "If there's an exposed port that you can connect to that gives you debug access or a shell, that would largely be an issue with a consumer device, because that means your consumer could do whatever the heck they want to with your device. But in the case of a high reliability system and generation, it might be significantly more important to have that as a means of debugging any issues that do occur with the device." Now I will highlight some of the differences and domain-specific perspectives of each group. Finding differences within this interdisciplinary group of participants is particularly insightful, as the differences highlight emphases and mindsets that can persist despite cross-domain experience. First, CyberSME's adversarial focus addressed gaining access to networks and resources, tracing paths across boundaries, modifying devices and their functionality, and exploitability. For example, of the participants who discussed exploit details, all 5 CyberSMEs asked how easy it would be to exploit the vulnerability, while 2 Energy OT SMEs asked whether it was actually exploitable. CyberSME's responses implied that compromise was possible, but that their consideration depended on difficulty, highlighting factors like how reachable the system is and the attacker's skill level. The more holistic emphases of energy OT SMEs focused on the overall system, potential disruptions in operations, and risk mitigation. For example, Energy SME E8 expressed concerns about distribution systems becoming more integrated, saying, historically, a distribution system was one radial feed. Now it's starting to talk to all the meters out in these residential areas. Energy OT SMEs also spoke in more detail about potential disruptions in operations. For example, participant E15 considered whether the location might be a high priority site that needs to maintain critical loads, and thus whether it would be among the last users to lose service and among the first users returned to service after an interruption. These different groups of experts can potentially complement each other in cross-domain interactions by providing exposure to other methods and other ways of thinking, and building overlap in understanding risks for energy OT systems. For example, cross-domain knowledge could help operators interpret computer security standards with more nuance, rather than mechanically following checklists or output from automated systems, thus building resiliency in the human operators of energy OT systems. Participants' own interdisciplinary experience informed their recommendations for cross-domain interactions. We echo participants' suggestions addressing collaboration between the two groups, such as the integration of siloed teams who could learn from each other, holding conversations that build mutual understanding, and conducting red team simulated attack exercises. Given limited resources and labor supply, we also encourage the design and development of tools and interventions that could help to effectively and scalably enable cross-domain knowledge transfer in energy OT contexts. Such work could also explore topics such as acceptable risk mitigations, patching. We also encourage future work interviewing or surveying experts who lack cross-domain experience to see whether starker differences in approaches and understanding appear. Finally, a larger scale survey might be able to shed light on our hypothesis that the interdisciplinary background of our participants led them to have similar responses. In conclusion, our findings characterize experts' approaches to impact assessment in energy OT contexts and highlight differences in focus, mindset, and understanding of energy OT SMEs and cyber SMEs. The problem remains that in practice, cyber SMEs and energy OT SMEs often lack cross-domain knowledge. Echoing suggestions made by our interdisciplinary participants, we recommend bringing existing teams together, fostering cross-domain conversations, and developing relevant training. We are also interested in future work exploring the perspectives of experts without interdisciplinary experience. Thank you for listening to my presentation.